How does the heart of a contact ignition system work? Let's take the distributor apart piece by piece and see everything from the inside. Ignition distributor. Aluminium housing. Bushings. Lubrication hole. Lubrication channel. The bushings require periodic lubrication. Distributor shaft. Breaker cam. The number of cam lobes corresponds to the number of cylinders in the engine. Ignition advance weights. Springs. The cam can rotate slightly relative to the shaft. Washers. Drive coupling. Pin. Retaining ring. The movable plate and the fixed plate are connected by a bearing and by a contact wire. Oil-soaked felt for cam lubrication. Fixed contact. Movable contact. Insulating bushing. Spring. Sliding block. Insulating washer. Wire. Rivet. Input terminal on the insulator. The electrical circuit begins at the input terminal. It passes through the contacts and exits into the aluminum distributor housing. When the contacts open, they break this circuit. Capacitor. Power supply of the ignition coil. The positive terminal of the battery is connected to the ignition switch. From the ignition lock, the wire goes to the positive terminal of the ignition coil. The second terminal of the coil is connected to the breaker input. The negative terminal of the battery is connected to the breaker housing. Let's connect the spark plug to the ignition coil. Sometimes a current limiting resistor may be built into the spark plug cap. We press the spark plug against the breaker housing. The ignition coil consists of a primary winding, a secondary winding, also called the high voltage winding, and a laminated iron core. When the ignition is switched on, voltage from the battery is applied to the primary winding of the ignition coil. The breaker contacts close the circuit, and the current flows through the coil and the contacts to the battery's negative terminal. The current flowing through the primary winding creates a magnetic field around the coil. This magnetic field magnetizes the laminated iron core. At this moment, a small voltage is also induced in the secondary winding, but it is too weak to have any effect. The capacitor condenser also has no influence yet, because it is short-circuited through the closed breaker contacts. When the breaker contacts open, current through the primary winding stops instantly. The magnetic field in the core collapses sharply. This collapse induces a high electromotive force, EMF, in the primary winding. The voltage can reach up to 200 volts. Since the contacts are now open, the primary winding becomes connected in parallel with the capacitor. In radio engineering, such a configuration is called an LC resonant circuit. Current flows from the coil into the capacitor, charging it. The electrical circuit closes again through the battery and the ignition switch, returning to the coil. At this moment, the battery acts merely as a conductor. Thus, the capacitor absorbs the current at the instant the contacts open, protecting the breaker contacts from burning and erosion. But EMF is generated not only in the primary winding. In the high voltage secondary winding of the coil, voltage is also induced. This voltage can reach 10,000 volts. Such a magnitude is enough to break through the spark plug's air gap and discharge as an electric arc. After the spark plug fires, the current flows to the engine body, then returns to the coil, completing the electrical circuit. This entire cycle can be represented on a graph. The contacts close. The battery supplies 12 volts to the coil's primary winding. The contacts open. The voltage in the primary winding rises sharply to about 200 volts. At this moment, the spark plug fires and the capacitor begins to charge. After the peak, the voltage begins to drop. When it reaches zero, the capacitor comes into play. It begins releasing its charge, but with reversed polarity. When the capacitor is depleted, the coil charges it again, but now with opposite polarity. This process repeats until all energy in the circuit is dissipated. Vacuum Advanced Regulator. Inside, it contains a rod connected to a rubber diaphragm and a spring. The spring keeps the rod pushed outward. If vacuum is applied to the port, the rod is pulled inward. Ignition distributor rotor. Retainer. Distributor cap. Spring-loaded graphite contact. The cylinder numbering in this engine starts from the radiator side. The connector slot for the first wire is marked on the distributor cap. In this engine, the firing order is first, third, fourth, second. When the engine is running, the distributor shaft rotates counterclockwise. Accordingly, the wires must be connected in a counterclockwise sequence, starting from the first wire. Third. Fourth. Second. When the contacts are closed, the coil is being charged. The cam opens the contact. A high voltage discharge is generated. Voltage from the central wire is transferred to the lead of a specific cylinder, depending on the distributor rotor's position. The voltage breaks through the air gap and travels to the spark plug. Before installing the distributor, the crankshaft must be aligned with its timing mark. And the camshaft as well. At this alignment, the piston of the first cylinder must be at top dead center, and both valves of the first cylinder must be closed. Now, the distributor rotor must be positioned to point toward the terminal of the first cylinder. The contacts are currently open, but they must be in the state just before opening. To achieve this, rotate the distributor housing counterclockwise until the contacts close. As soon as the contacts close, you should stop rotating the housing and tighten the locking bolt. Now you can check the gap between the contacts. To do this, rotate the crankshaft until the contacts open to their maximum distance. If the gap does not correspond to 4/10 of a millimeter, it must be adjusted. This screw needs to be loosened. And this one as well, if necessary. Then adjust the contact position with a screwdriver, so that the gap equals 0.4 of a millimeter. For one rotation of the distributor shaft, the engine's crankshaft makes 2 rotations. Right now, the spark is being delivered to the first cylinder. The crankshaft makes half a turn, and the distributor sends the spark to the third cylinder. Another half turn of the crankshaft, the fourth cylinder. Second cylinder. And then back to the first cylinder. The ignition timing correction system consists of 2 subsystems: the centrifugal advance mechanism and the vacuum advance mechanism. Both modify the spark timing, but they do so under different conditions and for different reasons. The centrifugal advance mechanism depends solely on engine speed. As the distributor shaft speed increases, the weights move outward under centrifugal force, shifting the cam in the direction of rotation. As I opened earlier, and the ignition occurs with advance, this is necessary to allow the mixture to burn completely at high engine speeds. The vacuum advance responds not to engine speed, but to engine load. When the throttle is partially closed and the vacuum in the intake manifold increases, the diaphragm moves the breaker plate and adds ignition advance. This allows the mixture to burn more efficiently under low and medium loads. When the throttle is opened sharply, the vacuum drops and the vacuum advance stops functioning. Thus, the centrifugal mechanism operates at high RPM, while the vacuum mechanism works under partial loads. Together, they provide optimal ignition timing across the entire range of engine operation. In contact ignition systems, a current limiting resistor is installed in the coil's power circuit. It protects the coil from overheating during operation. After the ignition is switched on, power to the coil flows through the resistor. When the key is turned to activate the starter, power is supplied bypassing the resistor, because the starter causes a strong voltage drop. This allows the coil to maintain its strength and provide a strong spark during starting. After the engine starts, the coil is once again powered through the resistor. That's all. Thank you for watching. Follow my social networks just in case: Patreon, X or Facebook. And see you in the next videos.